Okay, it's 10 o'clock, so we spend time that connections working well. So we are going to start with the SAURON pilot session. Hello, and as I said, good morning to everybody, and welcome to the pilot demonstrations. So under the SAURON project and Horizon 2020 project. So first of all, we hope that you are fine, and many thanks for joining us, for sharing your time during the next hours. I hope that you enjoy, and SAURON, we can share information and of your interest. Also, I would like to thank you to the partners due to the active participation during the project. And of course, to the CSP terminal, so the container terminal in Valencia, because it's one of the key actors here in this pilot during the validation of the pilot, and they have collaborated very actively in the project, and of course during the last weeks. Well, my name is Rafael Compain from the Valenciaport Foundation. I'm the coordinator of the SAURON project. And it's my pleasure to introduce the pilot session, the SAURON sessions. So, however, I would like to comment that some thoughts that we have. So, I know that it's a validation, it's a pilot session to test and to validate some of the technology that we have developed during the SAURON project. Our main goal was to do or to make a presential and a physical validation in a real environment, in a real scenario, in this case, in the container terminal, at the port of Valencia, to testing and validate everything. So unfortunately, due to the COVID crisis situation, we have found a lot of limitations, constraints, and so on. So I understand, and we understand, and of course we agree that for validation and for testing is better the real environment, but we have chosen this option, the option to make a virtual scenario or a virtual pilot in order to not delay the project for the next or many months in the future. So that is my thoughts. And however, we spend time recording images, threats, like a simulation of the threats and attacks in the container terminal. So thank you to container terminal and at the port that we will show to you during after the main presentation of the technologies. So, and I hope that you like it, and we will comment also the different actions and the different threats and how SAURON act against this threat, how to identify them, and how to inform to the population. Well, before the presentation and before to talk about the agenda, I would like to give you some minor rules about the connection. So please mute your micros and switch off your cameras. The cameras will be, only the presenters will appear during the presentations. Also, you can find on your screen a chat where you can write your questions, comments, queries, and everything. That we will collect them at the end of the presentation in order to discuss. We will spend time, half an hour, in order to reply you and to avoid and solve some of your queries. And of course, we also will send to you a summary of the session. We are recording this session, and we will send you the link in order to access after the presentation. So we start with the agenda. I would like to show you what are the different points of today. The first will be, I will give you a SAURON overview, a SAURON data cleanse in order to know the concepts. And secondly, we will comment the different components. SAURON is a platform where it receives information from different domains, from the physical domain, cyber, hybrid, and also send alerts to the population, to the citizen. So you can see there the different aspects of the situational awareness systems. So the idea will be explaining in depth the different components to clarify how to the interoperability, how to communicate the physical, cyber, and how to send the alerts, the interfaces, and of course, the different procedure of the warning system. Thirdly, will be a brief presentation of the Valencia project, where we will explain the details of the different attacks, how to, going to be detected by the SAURON platform, and so on. And after this Valencia pilot presentation, we will show a video where we're going to stop in every part in order to explain well what is happening and how SAURON platform is acting. And after the video, the explanation of the video, we will run all the video in order to understand well the whole scenario. And at the end, we will spend time with around a table with question, queries, discussing your point of view, and so on. And as you can see here in the agenda, the final one is a questionnaire that we will send you a link, and please, we will be very grateful if you fill it about your perception, about your comments, or any suggestion about it. Okay, then start with the presentation. SAURON project, as I said before, is under the Horizon 2020 program. It's a project focused on prevention of combined cyber and physical attacks. So in this sense, we propose different aspects, and we propose what's happening with this? Just a moment. We propose here a platform, a new concept in order to receive information from the cyber domain, the physical. So we create a platform which receives this information and send to the hybrid situational awareness system. And why we create this concept? Why we think that could be useful for ports? Well, as you know, you can find here some examples about cybersecurity attacks. So in the recent years, the security has changed. We are now with the digital transformation. Ports are installed sensors, and we find different threats in the IT systems, in the servers, and so on. So up to date, we find examples like the PETIA, the MERS systems, that we are talking about disruption of the value chain. So we are talking about economical impacts, very, very important economical impacts, but also we check that this security could impact in the life lost and the life humans. So then it could be very, very important to assure the security of ports. So here you can see in a slide where we show you the concept. So a cyber attack combined with a physical can, at the end, to suffer some explosions and so on. So the idea of the session, of the pilot session, is how SAURON identify the threats and how solve the situation. Because what is the concept of SAURON? SAURON, at the end, is provide information to the PFSO, so to the security officer, provide the information that is coming from the different sensors. In the part of the physical situational awareness, sensors like fire alarms, the CCTV cameras, installed in the different port infrastructures, smoke alarms, so all the information that is come from the different sensors installed at port are sent to the platform, the physical situational awareness, and also the information which is coming from the cybersecurity, so anomalies detection and so on, is sending through the cybersecurity situational awareness. So both of the information is correlated and analyzed and assessed in order to making decisions. So in this sense, when we talk about the security of ports and about the port infrastructures, I would like to show you a framework where we define the port areas. So you can see here, this is a picture. The reference is from ENISA. ENISA is the European Agency for Information and Networking. So we have used this slide because it represents well what is the situation. You can see here the different parts of the main activity of ports with the different areas, the vessel berthing areas, so also the different operations with the vessel loading and unloading and the different ends. So I mean the terminals, container terminals, terminals about solid in bulk, liquid in bulk, so we can find different activities, areas and operations, and also the different actions and services of the port authorities. Okay. Also, I like this slide, or we like this slide because apart from the port authorities and port terminals, there are other external authorities that we mentioned here, such as customs, police, coast guard, with who we will have in contact during the project in order to transmit and provide information, and of course, including and adding the comments that we receive from them. The next is particularly focused on the ports, on the port authority and port terminals, describing the different services, where we have analyzed many of the systems and many of the aspects related to the SAURON project in order to identify well the different assets and of course, keeping in touch with the authorities that I mentioned before, such as the customs, coast guards, border controls. So they are a main part of the security. So we have had a contact with all of them. The maritime port security during this project. I would like to say that the partnership is formed by important ports, the Port of Valencia, Port Authority of Piraeus, Port of Livorno, and Koper in Slovenia. So has been led by the Valenciaport Foundation, and also an important container terminal such like CSP Iberia Valencia. All of these ports are partners, and we have contacted with others because, other authority that has been identified in the project, they are not partners of the project, but we think that it's very important to be on board in different bilateral meetings, in different events. So they are a main part to send the main thoughts about the project. Here is only a geographical location of the different partners with the different profiles, technological, university, and the ports mentioned. And also we have a very important advisory board. So as you can see in this slide, with also limited is online, also security service, national, so seaports police also is online, that has been in a very active collaboration with us during the project. And also, in this slide, you can see the different components or the different elements that are the main part of SAURON. All of them are going to be explained in detail by the leaders, by the university, by the S2 groups, by the Austrian Institute of Technology and the ETRA. They are the leaders of the different components. But very briefly, I would like to mention that, for example, the PCA is the Physical Situation Awareness Systems. As I mentioned in the beginning, collect the information coming from the different systems, from the different sensors, cameras, fire alarms, presence detectors. Indeed, even drones, that we have tested drones during the project. The second one is the cyber, where we have the coordinator is the S2 group, who is a leader company in cybersecurity in Spain. So, and has included advanced anomalies detections in this service. And the hybrid situational awareness, a very innovative aspect because received information from both domains, from the physical and the cyber. And last but not least, the population warning system in order how to inform, how to send alerts to the population, to the citizen throughout the different authorities. What kind of innovative aspects? Well, I describe here some of them about the video processing new techniques, also about the hybrid situational awareness that I mentioned it before, the correlation between the different information of the from the different domains, advanced visualization, and the emergency population. However, we will explain many of them. We can discuss about the different innovations and the different activities developed during the project. And now focus, or particularly talking about the SAURON pilot. The idea here is, as I said in the first slide, is to test and validate the pilot. How are going to validate that? How are we going to know the results, that if the results that we have achieved are well and are in line with the project? So the idea is to validate the technology. So in this sense, we have checked the different installed sensors. What kind of sensors we have at the Port of Valencia? Well, you can see there a list, the CCTV cameras that cover the land and also the maritime side, to know what kind of threats we can find there. So also we have used the presence sensors, fire and smoke sensors, the use of drone that I mentioned it before, and other systems like the AIS and the use of tablets for communicating the information to the port police in our case. Other kind of sensors or sources coming from the cyber, you can see there, threats in the communication, the intrusion detection systems, anomalies detections, and different assessment of the assets and vulnerabilities of different systems. And one of the systems that we are crucial in a port is the terminal operation system. The terminal operation system is in charge, or is the responsible of the location of the containers at the terminal. So the idea here is to check and to assure the security of this platform in order to control or to be advised in case of any threat or any unauthorized operation. Then, very briefly mention the scenarios and pilots that we have developed during the project. The first one was in Piraeus with a focus on the cruises. Was simulated a terrorist attack in a large cruise with passengers. So the idea was to test the different technologies. So how the information is sent from the different domains, from the cyber and the physical, how is provide this information to the PFSO, to the security officer, and in order to making decisions, to decision makings, and then send an alert to the city, and now exactly how to act in the different traffic controls, panels, and so on. Another second pilot that we developed was in Sagunto. This pilot was focused only on drones. Due to some constraints at the Port of Valencia about drones, we decided to develop in a physical area, in real environment in Sagunto, where we demonstrate the importance and the interest that of the use of drones in port operations in order to monitoring and for the surveillance of the area. So we have more information at the website, sauronproject.eu, where you can find the different results achieved in these both pilots, in Piraeus as well as in Sagunto. And the next is the reason of the session of today. This is the final pilot. We are going to provide you the information from the different systems, and we are going to explain in detail in the next slide. Unfortunately, as I said, it's virtual, but I hope that we have the opportunity to provide information in remotely in order to guarantee that this kind of system, this kind of platform could be also operated so far away from the office, so could be a benefit of the use of or could be a benefit talking about a remote demonstration. And thank you very much for your attention. We are going to give the floor to the next presenters. The next presenters is about the different elements that I mentioned before. And the first one will be the presentation of the physical situation awareness. The coordinator here is the University of Valencia. So I start with the presentation, and also IDEMIA, that is part a collaborator of this activity with the university. So I'm going to switch off my camera in order to give the floor to the University of Valencia. Israel?
Yes, good morning to everybody.
Good morning.
I will share, I think now I'm able to share my screen. So we'll share it and we will through.
Israel, you have the presentation on.
Sorry?
You don't need to share your screen. You have the presentation already in.
Oh, great. Thank you. Okay, so 1 second. So you have it, Pablo, then? You're going to pass the slides, you, Pablo?
You can do it already.
Okay, so. Okay, perfect. Okay. So good morning, everybody. My name is Israel Perez. I'm from Technical University of Valencia. We are technical coordinators of SAURON project, and also we are responsible of several elements inside the SAURON platform. One of them is the physical situation awareness tool, the PSA, and we're going to show it now with also a relevant component of this tool, which is the video fusion module by IDEMIA France. So here we see the overall SAURON architecture definition, and on the left-hand side diagram we see the 4 main pillars or elements of the SAURON architecture, which is composed of the PSA, the physical situational awareness, the CSA, the cyber situational awareness, the hybrid situational awareness tool, and the emergency population warning system, which all of them are available for the both authority officers in order to use them and gain situational awareness and act over the port security on the physical, cyber, and hybrid domain, as well as to inform the population about a serious risk or danger. And also on the right-hand side diagram, we can see how both cyber situational awareness tool and physical situational awareness tool do provide information for the hybrid situational awareness tool in order to generate with the HSI engine these cascading effects in order to determine what's likely to happen in the near future about these incidents that are happening in the port. So one important element of the PSA is that this tool comes from an existing command and control tool, which is called HESTOP, and it has been adapted to the particular needs of the port environment in order to increase its physical security and in order to enhance or boost the situational awareness of the port officers. Also, this tool obviously can be adapted to different types of ports, and it has been shown or tested at this project as it has been used in the Piraeus port pilot and in the Valenciaport pilot, both ports with different traits, with different characteristics, and the tool has adapted to those differences. PSA is based on, as I was saying previously, in this Gestop tool, which is a civil version of the Spanish Army friendly force tracking system, which is called CIMACET, which also was developed by UPB. And also it's a tool tested on real field in harsh and hard environment and conditions, such as it is deployed in international missions of Spanish Army, such as in Afghanistan, Lebanon, and Mali. So we started from a real tool, which is used in international missions, and we have mapped it, we have adapted it to the needs of the ports. So this adaptation to the port environment has been done in several work packages and in several tasks in these work packages, mainly in the detection of vulnerabilities and physical risks corresponding deliverable, and also during all the user requirements stated, gathered, and feedbacked from end users, general requirements, HMI, data storage, and so on. And also this whole adaptation process is described in the corresponding document, Physical Situational Awareness Application, Adaptation and Integration with Existing Systems. So, one key element, obviously, in order to obtain this physical situation awareness is to gather information from physical sensors about what's going on in the hotspot, what's going on in the port and its vicinity. And those sensors can be categorized in the following categories. So we've been integrating, and it has been integrated at the PSA, presence sensors or detectors, video surveillance cameras, port police tablets, smoke detectors, AIS sensors or nodes, and its corresponding processing, and drone-based surveillance. So we will see afterwards when we see the tool, but mainly the tool, it's a GIS or map-based tool where the officers can see what's going on real time on a map. So they see where the units are located, they see where the sensors are located, and at any time, in order to access to those sensors, the officer, the user of the tool, just moves on the map and selects by clicking on a particular sensor icon in order to access the information related to that particular sensor. So regarding the present sensors, several sensors have been integrated. So on the left, we can see a particular sensor which sends its information to a hub, and this hub also in real time sends information to the PSA sensors manager, which also feeds on real time the PSA HMI with this presence sensor detection. So for instance, in this slide, we can see that a particular presence sensor has detected the occurrence of somebody getting into its field of view and has detected its presence and automatically triggers, flags, sends an alarm to the PSA, which is shown in the HMI as seen in the slide. On the other hand, also the CSP cameras have been integrated. So all the cameras from the CSP go to the CSP video manager, which also communicates with the PSA sensors manager, and then sends this information to the PSA HMI. So at any time, and by clicking on the camera icon for a particular camera, the operator can see on real time those video flows from the terminal cameras, as they are shown on the slide. Here there are other snapshots of the system working. For instance, an interesting camera, which is the control access camera. And another important element that has been integrated in the system is the port police tablets. So the PSA, not only it's a headquarters tool, but it is also a tool provided for port police officers in order to share with them situational awareness, what is going on real time in their tablets. So with the headquarters tool and also with the tablets, all the officers can see what is happening on real time and share all the information about relevant elements in the physical situation. Things that are exchanged and also integrated, messages. So there's a messaging capability between all the elements, alarms, threats, positions, and so on. Here we can see a diagram of this communication. So they are sharing data at any time with ad hoc mesh networks. And here we can see that these Police tablets do have a GPS sensor, so they send their position, and everybody themselves with the tablets and also the PSA application at the headquarters see where they are located at any time. Also here we can see the usage of and the visualization of threats using the UNOCHA United Nations standard, and also the location of particular objects. We see real-time video. And also these Police tablets do have the capability to exchange messages. So they can send and receive messages at any time among them or with the headquarters system. Other elements that have been integrated are those smoke sensors. Again, they go through the sensors manager and it sends information to the HMI. So whenever this smoke sensor detects a level of smoke exceeding a particular threshold, sends an alarm to the PSA tool, and that's shown on the screen. Another relevant element, which was stated by the reviewers to be needed to include in the system, was the integration with AIS. PSA has integrated with Valenciaport AIS infrastructure, and nowadays PSA provides information about real-time vessels data. So we can see it better in the next slide with a screenshot. At any time, if the operator activates the view of those vessels, can see where those vessels are berthed or parked inside the port, or if they are moving inside the port, if they are approaching the port, if they are located anywhere doing whatever maneuver in the port, we can see their location, their orientation, and also if one operator clicks on a particular vessel, can see extra information, such as, if available, for instance, the photograph of the vessel, or last seen position, or the type of the vessel, or the identification, whatever. And we do not limit ourselves to what's going on inside the port, but also, obviously, due to the range of the AIS, we can see vessels which are outside of the port range, as can be seen in this slide. And another relevant element which has been integrated in order to enhance this physical situation awareness are information about drones. So for the RockSafe Sagunto demo, it was integrated a third-party company drone, which sent information to a particular video server, and that was sent to the PSA HMI. Here we can see some snapshots from this Sagunto pilot, and we see the drone following the track and the location of the drone, and also the drone itself outside the tent where the demo was made. Here we see more snapshots from this drone. And also another capability that the PSA does have is the integration of third-party external sources, such as, for instance, in this case, Valencia's City Council cameras, in order to enhance the situational awareness of the operators. So we see here a snapshot of that information. And, well, in this snapshot, we see how is done the management of the sensors and its communication. Very simple, very easy for the operator to activate, to access to say particular data and such. And here we see how the user very easily also can add new sensors to the system, specify its characteristics. For instance, if you have an IP camera, add the URL of the camera and the location in a few clicks, and then you have the camera available for the system very easily. And here, another element that will be shown during the demo of today, the capability to have access to the events management and the communication with the HSA in order to control and generate events automatically or manually, and then send them, if they are considered to be sent, to the HSA system. On the other hand, this is about the face recognition, and I think, Pablo, there's been a problem with the snapshot.
Hello, good morning. Xavier Mami from Academia. I think it's my turn to speak, Israel.
Yes,
You
yes,
agree?
yes. I give floor. Yeah, we had another bit. Yes, yes, please. I give floor to you, Xavier.
Okay, thank you. So as I said, Xavier Mami from Academia. So in SAURON, well, our role was to develop and integrate video analytics for intrusion prevention and detection, meaning video innovative algorithm that can process the video stream of the cameras of the ports and raise alerts, live alerts, real-time alerts. Our algorithm can detect faces, person, vehicles like cars and even boats, vessels, and they can detect and also identify person in database. It's based on artificial intelligence, deep learning. It works very well. At the right of the slide, you can see a basics description of how it works. You can see so we process the video stream of a camera. We can detect faces. We extract each face and compare it to, for example, a personal database, and we can check is it in the database or not. If it's not, the person is not authorized. If the person is in the database, we can check is the person authorized at a specific time and a specific location in the port, and so raise an information, an event, or an alert. Next slide. Okay, I can read myself. Here are some snapshots of extraction of detection done on the video stream on some camera of the ports. We can see the first one on the upper left is face detection. Then person detection. We detect the whole body. We can also detect car and even boat detection. At the bottom of the slide, you can see for boat detection, it's only at research stage so far, but it works. We just need more data to let the algorithms learn better, but it works. So we did an integration into the whole SAURON system. We can see a video processing module. It processes the video stream of the connected and cameras, and it sends alert to the video fusion module of PSA. We also have an internal live monitoring interface, which allow to use more features that we develop, like to track people, to do some requests, like find the guy with a red shirt and a yellow backpack, for example. In the Valencia scenario pilot, the idea is to detect unauthorized persons that are not in the database. So that's what we did. We compare the extracted faces to the database, and they are not in the database, so we send an alert. For face recognition, of course, we need good positioning of the camera in order to have a good quality of the faces. And there is many ways to implement it. Here it's an open access, but you can imagine to plug it with access control gates, meaning doors that you can open or not, depending of if the access is authorized or not. The face recognition, it's frictionless, it's contactless, and that's a good thing for this technology. Of course, we can detect other events, as I already say, like person vehicle detected, person recognized in the personal database and authorized or not authorized, or you can have a blacklist, meaning people that you want to detect with a high priority and raise alert. Okay, here it is difficult to have an idea of the accuracy of the system because you did not test it. But just to reassure you, there are international benchmarks done by, for example, the NIST, which is an independent company institute. It tests all the algorithm from all the companies all around the world. And in biometrics, Academia is really at the top state of the art. And we are, for example, here you can see at last NIST benchmark FRVT, face recognition vendor test, one-to-many comparison. We are one of the best competitors. We are even better than Microsoft, for example. And so just to say that face recognition now works well due to breakthrough technology 5 or 6 years ago with deep learning enhancements. And we also have other devices for security that allow frictionless and touchless control check, security check. It can use face or iris or even fingerprints, because we have device without contact. You just wave your hand before the sensor without touching it, and it gives you access on it. Thank you.
Okay, thank you very much. Many thanks for your presentations. And then we carry on with the next presentation about the cybersecurity, the cyber situational awareness. I would like to comment that, as mentioned it in the beginning, we are collecting your questions and comments from the chat, and we will dedicate and spend time at the end of the presentation in order to discuss all of them. Okay, so then carry on with the next one with S2 Group with Sergio. Sergio, please, the floor is yours.
Thank you. Nice to meet you all. I'm Sergio Zamaripa from S2 Grupo, and I'm in charge of the work package leader for the CSA. The CSA is complementing what with my colleagues just mentioned, is the cyber situational awareness system, and is based on the detection of cybersecurity incidents in the scope of SAURON. Okay. I'm going to present in this section what's the main elements of the components that have been developed within the project. Okay. First of all, this is a summary of the modules that are part of this CSA component. CSA, the first of all, is a cyber situational awareness system, which aim is to prevent and detect threats in case of a cyber incident or a declared attack. And the idea is to ease the work of the people in charge of the cybersecurity in port authorities that are using and have SAURON installed. Regarding the different modules that are available for the CSA, they are related to the information flow. First of all, we deploy a set of CSA sensors, cyber sensors in this case, having monitoring information about the network traffic, about the host-based intrusion detection system, any login, failed or successful over any machine, any access from remote SSH connection, and not only that, but also sniffing the network traffic in the organization of the port authority. So the CSA sensing is both the set of sensors that are deployed across the port authority based on host-based intrusion detection system, network intrusion detection system, and also vulnerability assessment or vulnerability audits of the versions installed in the different servers of the port authority. And apart from that, it is also a set of centralization of logs. This information is centralized into a centralization log system, which is also the CSA sensing that you will see during the demo. And all this information also goes across the following module, which is the CSA correlation. The idea of this correlation is to narrow from big millions of messages which are hiding a possible cybersecurity incident based on expert knowledge. And the idea is to be able to detect automatically in real time what is just happening and if we are facing a cybersecurity attack, as we will see in the scenario of the pilot. Once this information goes across the CSA correlation, it will fire possible CSA alerts whenever a cybersecurity incident is currently happening. And the idea of the CSA alert module is to represent this to the CSA team of the Port Authority, in order to have the fully contextualized information of the cyber incident and be able to manage the alert lifecycle. And finally, we have another module, which is the CSA visualization, which gives an overview in a very visual way to see at a glance what is going on, where, when, and what to do with it. Okay, so it's a multidimensional approach to improve the representation for the people in charge of mitigating the incident. This is the layers of the CSA. We see as a funnel that we have a lot of information in the upper side because we are monitoring everything. Then the CSA sensing gives the overview in the centralization logs, but the CSA correlation narrows to what is really important and what is meaning a cybersecurity incident in order to throw only the alerts that require an action from the cybersecurity team. Okay. Going next, these are the main technologies and libraries that we have used in the development of the CSA. For the CSA sensing, it's based on PHP and Python. We use Greylog as a centralization log technology, and we use for sensors, as we were mentioning, NIDS with Suricata, HIDS with OSEC, and also with WinEventLog. And with vulnerability, we use Nessus for the vulnerability audits of all the systems involved. Regarding the CSA correlation, we have used Java technology, using rules as a correlation engine, and having Spring integration in order to communicate all the messaging systems. And concerning the CSA alerts, it's also developed in Java, and the idea is to have a visual interface in order to manage the cybersecurity incident, to have the description of what happened, the criticality, the responsible, and have a full life cycle of the incident management, complementing with work notes, and also to have the final solution in order to see that everything was mitigated in terms of the cybersecurity incident. Regarding the CSA sensing module, this is a picture. We can see all the possible classifications of the monitoring that we have. This is, for example, the NIDS with Suricata, and we can see what is getting from the port mirroring in the network traffic. So we can see some patterns of malware, of SQL injection, of possible attacks inside the port authority. Regarding the CSA correlation module, is based on the use of correlation rules. This is an example, and the idea is to have automatic alert generation without any human intervention. The idea is to, whenever some of the conditions are satisfied in the antecedent of the rule, and only when these conditions are satisfied, in other words, when something is going on in terms of meaning that there is a cybersecurity incident, then the consequence will be executed. And usually the consequence is to generate the CSA alert to be managed by the team. And here the CSA alert module is representing into a console what is the current set of alerts that are detected in real time based on this CSA system. And very importantly, to have the possibility to have all the information contextualized of what happened, when, and what to do with this kind of malware, for example, and which are the references of this type of attack, so the users of the CSA can easily know what to do in each case, depending on the classification of the attack. This alerts module also has a dashboard with situational risk, having the type of the incidents that we detect, the origin of the communication, and the criticality of each one of them, in order to know which is the current status of risk based on the criticality of the CSA alerts that are being detected. And not only this, but also the typology. If we are suffering more from malware elements, from malware incidents, from intrusions, from compromising of the information because of information disclosure, the integrity of the information is compromised, that kind of things. This is the cyber view. The final component is the CSA visualization tool, which is the cyber view, and the idea is to have at a glance what happened when you see the bullets in red or in different colors, you know exactly what happened in which asset. And based on a code of colors, we already know, based on the typology and on the color, we know the typology of the color. If it's a malware, it's a color. If it's an intrusion, it's a different color. If it's an illegal or unauthorized access to a concrete asset, it's a different color. And the idea is to have a location view to know when did it happen, and the information on what happened is in the CSA alert. And also we have complementary information about the vulnerability assets of the vulnerabilities affecting the asset that has just been affected in the CSA alert, and also the connection between one asset and others. Apart from that, the CSA cyber view also has the possibility to have the 3D glasses in order to have a better user experience in order to manage all the elements. And all these sensing, correlation, CSA alerts, and cyber view are supporting this CSA team based on the located in the Port Authority, or managing the security services of the Port Authority, having a team organization based on a tier 0, which is based on the tool, on the CSA, because the tier 0 provides the information already contextualized in real time and automatically detected. Then it supports the tier 1, which are persons with a high level procedure. Depending on the type of incident, they will be managing the incident based on a procedure on how to proceed in each case, if it's a malware, if it's an intrusion, or if it's a legal access. And in this next level, there's a tier 2 based on the kind of incidents that are more new and that are not procedured yet. And it's based on analysts. And the system also detects this kind of new attacks, but this tier 2 is in charge of making the procedures so the tier 1 can support also more types of incidents. And finally, the tier 3 is based on coordinators of teams and also vendor support and specialized incident and threat hunting, and also the directors as well. This is what supports the whole cycle supporting the CSA. First, the CSA identifies, selects, correlates the alerts, and performs a first analysis. And finally, it notifies the alert. Then the team what has to focus is on containing the cybersecurity incident, on performing eradication and recovery in order to isolate the affected asset if it's a malware, or to remove it from an antivirus in that case, or to blocking, for example, a denial of service. And then finally, there's a final phase, which is the analysis, in order to perform lessons learned, in order to be included again in the tools, to be able to complement and contextualize to a greater extent each one of cyber incident, in order to have a continuous improvement. So finally, what's the innovative systems of the CSA? We have included visualization techniques in order to identify the incident at a glance, and in order to be able to see what happened, what kind of type of a cybersecurity incident, where did it happen, and how, and also who did it, from which IP address, which user was compromised, and also performing actions in order to explain how to proceed. And also to have the impact visualization with the asset vulnerabilities of the CSA, the cyber view. And also we provide external awareness. We have another component that performs digital surveillance in order to see real-time cyber incident detection over seaport infrastructures. And we also have improve the seaport cyber critical infrastructure based on cyber incident contextualization of the incident and guiding the required action for the people in charge of the Port Authority. And basically, this is the end of the explanation of the CSA component. Thank you.
Okay, thank you very much, Sergio. So then we move to the third element, the hybrid physical situation awareness. So which receive information from both domains, cyber and physical, and correlate the information in order to send to the security officer. So the floor is yours, Romain.
Can you hear me well?
Yes.
Okay, so hi everybody. So Romain Caillard from Thales Research and Technology France. Now that we have seen how to create and enhance situational awareness for physical part and cyber security part, we will see how we can enhance the overall situation awareness using the hybrid situational awareness, also called LCSA, with Stefan. So first, to replace it in its context, the HSA is directly connected with the physical situational awareness modules and the cyber situational awareness modules, which will send a message to the HSA. And the HSA is composed of 4 sub-modules, which are the application core, the event correlation engine, the threat propagation engines, and the human-machine interface or visualization tools that was mentioned by Israel before. So now we will present you the different how work the different sub-modules of the HSA. So first, the application core. It's the modules which is in charge of managing the communication of the system, which means that it will receive messages from PSA and CSA, check if the message are valid, check if the route are valid to the correct subscribers, which are in our case the different submodules of the HSA. And we designed it, the application core, in order to follow the system evolution, which means what? First, that it's easy to integrate new types of messages. For example, if you want to add a new functionality in the systems, it's easy to add a new type of message to support this exchange where new events. Secondly, it's easy to integrate new HSA submodules, dealing with different kind of event and alert. For example, if you want to add a new visualization tool or something new to new computations, it's easy to connect it to the application core so that it can exchange messages with the rest of the system. And to finish, it's easy to integrate new module outside the HSA. For example, if you need a new module aside PSA and CSA, it's also possible to connect it to the application core so that it can exchange with the rest of the system too. And finally, the application core is easy to update and maintain if necessary. So now we'll see some functionalities of the application core, which can give feedback to the operator in order to check what happened in the application core. Specifically for the validation of the message, the operator is able to see if the message are well sent to the different submodules of the HSA. It is able to see that the message are well received and valid from PSA and CSA, so that the message fit the different schemes that were defined for the message. And it provides the content of the message so that the operator is able to see what is inside the message that is sent to the HSA and shared. And to finish, it gives an overview of the status of the exchange server, which means that the operator is able to see who and when is connected to the broker to exchange message, to see the list of the current user connected in the system, and to have a little overview of the different message exchange through the broker. So now we will see the second submodules of the HSA, which is the event correlation engine. So why using such engine and how it works? So it is used to identify related cyber and physical events in order to enhance the overall situational awareness of the systems. So how it works? First, it will receive the different messages, the continuous flow in real time of messages coming from PSA and CSA, and it will only pay attention of the relevant event. So what is a relevant event? It's an event which belongs to a pattern of our rule that we want to recognize inside the flow of event coming to the engine. So a rule of a pattern we want to recognize is constructed with a set of with a combination of events which will trigger a specified event or an alert that we want to send to the threat propagation engine or to the visualization tool. So now I will give you a little example of a scenario which will use this kind of hybrid correlation to detect an unusual pattern in the flow of events. So, for example, on the PSA part, you may have a camera with the link to the IDEMIA face recognition system, which detects that the PFSO, for example, is leaving the port. So it's a usual event on the PSA side. There is no problem for this. At the same time, on the CSA part, we can have a user which using the credentials of the PFSO who just leaves the port, connect on its laptop with its credentials. So from the CSA part, there is no problem too because it's a usual event. But at the hybrid side, we can see that this person is at the same place. It's at two places in the same time. So there is a problem that we can see at the hybrid level, and we can so trigger an alarm for the operator. So now to finish with the correlation, the event correlation engine and its added value. So first, it does correlation, so which means it is able to combine events to recognize a specific pattern, which will trigger alerts or the events which will also declare alert after. In our specific case, it will do hybrid correlations, which means combining physical and cyber events, which are used in point of view of on point of view of PSA and CSA are usual, as I said before. For example, face recognition, logging, and a card reader, for example. So that's our usual events from the point of view of PSA and CSA. But at the hybrid level, we can see that there is some problem. We can detect unusual situations. And to finish, so this kind of engine is able to deal only with relevant events. In our case, the spatiotemporal events, which facilitates the management of a continuous flow of information. So thank you very much, and I will leave the floor to Stefan.
Okay, so please switch on the camera, please. Stefan?
We cannot hear you, Stefan.
We cannot hear you, no? Not yet. No. No, we cannot. So check again with the audio. Okay. Press the button and enter the micro. So sorry for that, but that is some error of the real scenario. So okay, you have unmute your micro. No. Working. Wait a few seconds. If not, maybe we can show the slides, and maybe Romain could comment a little bit the part of AIT. Or maybe Sandra Koenig will connect and give the presentation in very briefly. Okay, Sandra, if you check the mic again, you can enter with to talk. And Thomas, can you comment also the slides from IT?
Can you hear me?
Yeah, yes, yes, please.
I can try.
Okay, perfect. Please switch on your camera, please. Very briefly, in order to understand well the correlation engine of the hybrid situational awareness.
Just a second. Okay.
Okay, perfect. Thank you.
All right. So the next part is we from AIT were responsible for implementing the threat propagation engine. Next slide. Yeah. Right. So the purpose of the threat propagation engine is to evaluate possible cascading effects if an event happens at a specific asset, for example, a server or a camera or whatever. This can have cascading effects on other assets in the port that depend on the service or on the physical presence of the asset. So what the threat propagation in principle does is it needs a graph-based representation of the port. So each asset represents a node in this graph, and the edges between those assets they represent dependencies between them. So the source of the edge is the providing node or asset, and the target is the dependent asset, which needs the service or the existence of the other assets in order to function. Second, each asset has operational states that it can change to based on an incoming event. So in case of SAURON, we used 3 different states, where one is operational, 2 is affected. So this means the asset is still working, but it is restricted in its servers. And the third one is completely not operational. So the asset is offline or is not working anymore, cannot deliver a service or fulfill its purpose. So this is the inner model of each asset, and to change the state, the change of each state depends on the incoming event and is linked to a certain probability. For example, on this slide, we can see the server has 2 alerts it reacts on, or events. One is virus, one is fire. Depending on its state, the probability to change to another state is different. For fire, in this example, it's always 100%, because if the server is on fire, it doesn't work anymore. So it goes into with 100% probability in the next state. Right, this is the inner model of each asset. And then we need an initial alert that triggers a possible cascading effect. So what the threat propagation engine then does is simulate a possible cascading effect by forwarding events. If, for example, the server is triggered by the event virus, it also outputs virus to all dependent assets. In this case, it's only one, the switch, but an asset can provide a service to multiple other assets, or in other words, an asset can be dependent from multiple other assets and can receive incoming events, and thus this threat or this event propagates through the network of dependencies in this model. Right. The outcome of such a simulation is a timeline for each asset, telling which states these assets switch to, and by running multiple simulations, there we can aggregate this outcome to provide a distribution to the visualization of the whole project. Which states were triggered the most, which was the most origin, which asset was responsible the most, and which event was responsible the most. And this is basically what the threat propagation delivers as output to the HSA again, which is then forwarded to the visualization. Right. The incoming events are, of course, from the PSA and CSA, forwarded by the hybrid situational awareness module, but can also come from the event correlation engine that detects additional events. So what the threat propagation takes as input are events from different sources, right? Yeah, and that's about it. It's about my capability of explaining threat propagation engine.
Can you hear me now?
Yes, we can hear you.
Oh, okay. So sorry, I'm very sorry for this inconvenience. I had to log out and log in again. So
okay, carry on, Stefan.
Yeah, I think it was very well explained, of course, by Thomas, who did a lot of work implementing the general framework for the threat propagation. Just to summarize, the hybrid situation awareness, as mentioned in the beginning, is one of the core aspects, and it implements, or it realizes the fusion between the physical and the cyber world. So what you can see here, you would have alarms coming from the physical and alarms coming from the cyber world, and they are connected. So the hybrid situation awareness, in the end, should give you an overview on things that could happen, incidents that could affect the overall infrastructure that each of the individual situational awareness products could not identify by themselves. And therefore, the event correlation is necessary, and the threat propagation that Thomas just explained is to give you an overview on what things could happen, which systems could be affected, what would be the cascading effects of a specific incident, not only within one domain, but within both domains, so within the whole infrastructure, the whole environment of the port. And of course, the identified incidents and the effects can then be forwarded to the emergency organizations, which brings us to the next step, to the emergency population warning system.
Okay, many thanks. And yes, we have had a live incident, a live problem with the connection, but okay, has been solved. So okay, then we carry on with the fourth element of the SAURON platform. So here we have seen the main system, so situational awareness system, which receives all the information, and then this information is sent to the project office, to the project PFSO, to the security officer, in order to decision makings. And then, depend on the alarm and the threat and the event, activate how activate the alert throughout the emergency population warning system. Here, the leader of this task is Etra, and so Jordi, please connect your camera and explain a little bit what is the procedure of the warning system and how to work it. Okay, thank you very much.
Thank you very much, Rafa. Okay, can you see my screen and my face?
Your camera is not connected yet.
Now, yes?
Yeah, now it started. Okay, perfect.
Okay, thank you very much to all of you, and thank you, Stefan, for the explanation. Well, this is the last part of a set of tools in which SAURON has been working. In ETRA, we have been working in the EPWS. It is how it's called. This is the Emergency Population Warning System. The main contribution of the EPWS is becoming a platform capable of providing an enriched set of homogeneous data. So this single platform aggregates the information from the different sources within the port, the information provided by the cameras, by the sensors, and also the information provided by the cyber part. So the authorities have an entire situational picture when they have to make a decision. And cities have as well a single source of information. So this allows implementing the decision taking in the best and the most efficiency way. Okay, for the next slide, okay, sorry. Okay, as we explained it during the whole project, the main mode of communication in the SAURON project is through the smart city platforms. So this was considered a key target for the project, and we need also an operator, being the ports the target in this case. So as I commented before, the added value is that all the relevant information and actions will be handled through this single platform, avoiding unnecessary duplicating interfaces efforts. Okay. In order to have a complete test, the EPWS will need to interface with a massive broadcast mechanism as a TV, radio, but also specific mobile alert channels. So obviously, this is not possible to propagate an actual alarm, even as a simulation in the context of a research project. Okay, so therefore the EPWS is able to notify through different means such as email, public or private channels of Telegram, social networks such as Twitter. It is able to communicate also with the regional emergency centers, the 112. Okay. The EPWS is also already connected with the traffic control systems. It's also already connected with the public transport systems and also with the smart city platforms. In this case, in the context of the Valencia pilot demo with the fireware. Okay, so I will explain later on how we are already connected with the smart city platform of Valencia. So essentially, the EPWS is capable to be connected with any system capable of receiving and managing an alarm notification. Okay, essentially, this is how it works. The EPWS has a sophisticated configuration system capable of interacting with the different authorities. Making use of smart city platforms deployed in this case in the Valencia city. It can be propagate an alarm in a variety of different ways. As I commented before, with the traffic control system, with the public transport systems and emergency teams in general. It's able to publish text feed in a common alert protocol format, and is able to publish messages in public networks as well. We provided also the use of workflow systems to manage incidents specifically for each type and for each city port. So essentially, the workflow systems allow to adapt the notification strategy to the different ports. Okay. Once the alarm is triggered by the HSA, it will be then up to the city or the configured entities to establish the appropriate coordination with the rest of the vertical systems. As it could see, the traffic system with the emergency services following the existing emergency plans. So essentially, the EPWS receives the alarm from the HSA when it is correlated by the physical or by the cyber part. This information is categorized, and then once the alarm is triggered, the notification systems reach to the different systems according to the needs of each city. Okay. Well, this is the general architecture. Essentially, here what we have is a general structure or the architecture of how the EPWS works. We receive the alarm from the different technical components, the physical, cyber, or in this case with the correlation of the hybrid part. And we have an open API in which it is possible to publicate or submit information to the relevant actors. The workflow engine allows to adapt this information to the different means as social networks, to different email accounts, or any entity capable to receive this alarm. We have also a web interface in which we will see later on during this presentation and also during the video demo how it's possible to manage an alarm thanks to our web service. Okay. In the next slide, once the alarm is triggered, it can be notified as I mentioned before through the smart city platforms, through the traffic transport system with the public transport system as well. And we included it was not stopped in the beginning of the project, but we considered that it was necessary to implement a key new element. This was the voice system, and we made some exercise in order to improve the EPWS in order to address the voice systems. So the EPWS, apart from connect with the smart city platforms, apart from connect with the public transport system boards and the bus stops boards, it is able to also to spread an alarm in a voice way. Okay, so this is something that, as I commented before, it was not thought in the beginning of the project, but we consider a key element in order to spread the alarm for the citizens as much as possible. Okay. Okay. Essentially, in this part, this is an example, but it will be shown during the video demo how the alarm is spread through the public transport system of Valencia. Okay, when the bus or when the public transport system receives an alarm, it will show a program image from each type of alarm on the information boards. So these different information boards, it was installed in various bus stops, very close to the area of the Valenciaport. Okay. So we will see how it works in a real context in the video demo. Okay, we were integrated also in the smart city platform of Valencia. Okay, this smart city platform integrates various municipality services that are considered priority by the Valencia municipality. These are the public lighting, the technical central services, the local police, the fire and emergency departments, public transport, and so on and so forth. So the EPWS standardize all this information provided by the HSA in order to contextualize an emergency to this smart city platform. Okay, for example, in the case of fire in the port, as we commented for the pilot demo, the EPWS is connected to the smart city platform, so the incident could be routed to the fire department, being in this case the smart city the last responsible in defining the different actions to tackle this emergency. Okay. We are also already connected with the city's traffic system, so it is possible to activate predefined traffic plans for certain levels of alarms associated with the port. So the interoperability done in this case was through an authenticated web service to the traffic system. Okay. The EPWS, as we commented before, it's also integrated with different social media channels. We provided an example in the slide with the Telegram API, and it is possible to send messages to different channels. We use also another different communication channels, as for example email and Twitter also. And essentially, we are able to integrate it with other internal or external systems through invocation of authenticated web services. So essentially, we are able to connect with any systems capable of receive an alarm. Okay. Well, in relation to the workflow process, well, there is, in some specific cases, that the ports or the authorities only own or they don't have any an smart city platform. So in this case, the workflow system allows adapting the notification strategy according to the needs of each port. So essentially, if the authorities, for example, only own a series of web services where the emergency data needs to be reported, the EPWS can be configured to consume this information appropriately. Okay, so that is how it works. Essentially, the workflow it's able to adapt to the different notification strategies. Okay. Also, the workflow has a particular flow for its target authority, so it can execute all sorts of actions, from calling a phone with a record message to sending an email, or use different communication channels, like publishing this data in the Common Alert Protocol format. Okay, so essentially, I included an example in the case of the Valenciaport. Okay, essentially, when the workflow system has to deal with an alarm, maybe it could be necessary to proceed in a more complex protocol that simply notify to the outside world that an incident has taken place. So a procedure may involve activating a 112 web services, entering a data form, making a phone call. So these all sort of actions we consider it essential to be automated. That's the reason of why we consider the workflow system a key element for the EPWS. Okay. And And finally, that's essentially how it works, the EPWS. The EPWS is capable of be adapted to any kind of platform that could receive a notification, and also it can proceed in a way to be automatically trying to reach the maximum number of platforms. So this is essentially how it works. This is the HMI. So this is the web interface in which it will be explained later on how it works. Okay. So thank you very much. I will give the floor to Rafa again.
Okay. Thank you very much, Jordi. Well, up to now we have commented a little bit the difference, an overview of the project, and also have explained the different elements in detail. So the idea is now to comment the pilot, so the pilot grid that we have organized. So this pilot grid, Pablo from the Valenciaport Foundation will explain the different actions and that we have recorded, and you will see in the video. So the floor is yours, Pablo, please.
Thank you, Rafa. So as Rafa was saying, the idea now is to explain you what is going to happen during the scenario in order you have a clear idea before we start. Okay. First, I'm going to give you some information. We told you before that this is the third pilot. We have a first one last year in the Port of Sagunto, showing some of the capabilities of the SAURON platform. Then we have a full pilot in the Port of Piraeus, and now we are in this third pilot. Which are the main objectives of this pilot demonstration? We want to validate the work done and the components developed during these 3 years in a real environment. And also we want to show the port operators how SAURON can detect and anticipate potential cyber and physical threats, and mainly combined threats that are the most dangerous. Okay, as you know, our plan was to have this pilot event physically in the CSP Iberian Valencia terminal, but finally, due to this situation, it was impossible. In any case, SAURON is connected remotely with real sensors in the port. For this scenario, we have 2 different locations. First, we have the Port Authority premises, and then also the CSP Iberian Valencia terminal. And as my colleagues showed you before, this is the integrated sensors that we are going to use during this pilot scenario. We have in the physical side the surveillance cameras. We have also a presence sensor and a smoke sensor. We are going to use also the tablets by the security staff in the terminal. And then we have integrated also the AIS and PCS systems. In the cyber side, we have sensors for detecting network and host-based intrusions, and also a sensor for vulnerability scanning. So now, moving on to the scenario, the global objective of the terrorist is to activate and detonate a bomb inside the container terminal. For that, some days before the attack, the terrorists send an email to a terminal employee with a fraudulent email with a link, which when the employee clicks on it, malware is downloaded and installed in their computer. This malware allows the terrorist to have remote access to its computer. Then, the day of the attack, a vessel arrives to the port of Valencia, which has a container with the bomb inside it. Then, thanks to the compromised computer, terrorist has access to, as you can see in the figure, with other systems that are in the same network in the terminal. And they are able to access the TOS system, the terminal operator system of the port, which is the system used to manage all the containers in the yard. So the terrorists, with accessing this system, are able to relocate the container that includes the bomb and put it in a place where it's easy to access and without camera surveillance. Then they go to the Port Authority building and they initiate a fire close to the server room in order to disable the cameras that are in the surroundings of the terminal. After that, they go directly to the terminal and they jump the fence perimeter and they have access to the yard. So they go inside the container and activate the bomb. Once the bomb is activated, they want to leave the terminal. So they start a fire in one of the terminal buildings in order to escape during the evacuation of the employees. However, the SAURON face recognition system detects these two unauthorized people while they are leaving the port, and the information is sent to the security staff tablets, and finally the terrorists are arrested. In any case, the port security officer decides that a bomb threat is a severe incident, so they decides to send information to the proper authorities, which, following their protocols, they warn the population through different channels, as you can see in the figure, with the traffic panels, the bus panels, and also the Valencia Council application. And also with some public channels like Twitter and Telegram. Finally, the bomb is detected and activated thanks to the use of SAURON that helps the port operator to make decisions. That's all. Now we are moving on to, Rafa, to the pilot demonstration.
Okay, thank you very much, Pablo. So, well, we have seen the elements, and now, as you can see, it's a particular case of a scenario. So the main aim of this video that you are going to see and the explanation of Pablo is demonstrate and validate the technology. So the most important for us is, well, we have different sensors which have to interoperate between them. So smoke sensors, presence sensors, cameras, AIS, drones, and so on. Also, we have another domain called cyber, where we receive threats, and we can have, such as mentioned by Pablo, malwares and anomalies in any procedure. So the idea now is validate that the systems are communicating between them, send the information to the hybrid situational awareness system, and then send this information to the officer, the security officer, in order to the decision taking. So we can use other elements, other sensors. We have defined the installed sensors with the idea of demonstrating that we can test everything from the different domains, and then we give the result, the expected results. Okay, so then please move onto the video. Well, sorry, before we are going to analyze and assess the video step by step. In each moment, as Pablo said, we are going to present by the difference coordinator what is happened, what occurs in the different situations. And after this first version, step by step, we will run the video as the full video. Okay, so you will have the opportunity also to have the full video without any stop. Okay, thank you, and please.
Hybrid situation awareness system, combining physical security systems with cybersecurity tools. SAURON takes advantage of the monitoring systems and sensors already in place in ports. It integrates them and analyzes their outputs in real time. When a new threat is detected, be it physical or cyber, all this information is combined and analyzed and is made available to facilitate decision-making. The result is a joint operation tool, which assists different operators in their decision-making upon the occurrence of a combined threat, helping them to act quickly and aiding prevention, thus guaranteeing the protection of critical port infrastructures and people. The Port Authority of Valencia, which trades under the name of Valenciaport, is the public body responsible for running and managing 3 state-owned ports along an 80-kilometer stretch of the Mediterranean coast in eastern Spain: Valencia, Sagunto, and Gandia. Valenciaport is the first and last port of call for regular shipping lines operating in the Western Mediterranean. As a hub for the entire Western Mediterranean, Valenciaport efficiently distributes goods over a radius of 2,000 kilometers, both in southern EU countries and in North Africa, representing a huge market of 270 million consumers. Roughly the most important figures in 2019 for Valenciaport were around 81 million tons of total traffic, 7,900 calls vessel, 5.5 million of containers, 1,113,000 passengers, and 723,000 vehicles. In terms of container throughput in 2019, it was the 5th port of Europe, the 2nd of the Mediterranean, and the 1st of Spain.
Okay, we have seen an introduction of the framework of SAURON and also an introduction of Valenciaport, where is the real scenario, where we are going to develop the pilot scenario. And you will see now in the next image how the cyber situational awareness works. So through a malware, so please.
Valencia pilot scenario. Some days before the attack, a terminal employee receives a fraudulent email with malware. The attackers take control of the computer.
Okay, so here the malware is detected is inside the computer. So now S2 group going to explain well how we identify an anomaly through the cyber situational awareness and how we send this alert to the hybrid situational awareness. So S2 group and the university will explain in depth what is happening, what occurs with the SAURON, how is working the SAURON system. Okay, please. So university, you can switch on also the camera if you want, both of you. Okay.
Sure. Okay, so first of all, I'm going to share my screen. This is this one. Okay. Okay, first of all, this is the environment that we are going to use to represent this demo. And what we are about to see is we have the traffic that we can see whenever a real situation of malware being installed and running is sending to the network traffic. Because the idea is that the CSA, as I was mentioning before, the idea is that the sensors are continuously sniffing the network traffic of the organization, and they are looking for patterns of malware. These patterns of malware, in this case, is going to be a backdoor remote access Trojan that, as my colleague Pablo explained and you saw during the video, was inserted in the port authority through an email, an external email from the attackers, changing the origin and seeming like something nice to click on, and the employee clicked on the email, and then it behind it installed the malware. So what you're about to see is the simulation of this traffic. So this traffic is going to go through the CSA sensing. You will see that in a moment. And this traffic is also being shown in the log centralization. It will go through the CSA correlation, where we have rules for malware detection, and it will be shown in the CSA alert system. Okay, so finally, at the end, in the CSA alert system, what it will do as a final action is to represent the alert, to give the information to the CSA operators, but not only that, but it will also send information through the interaction or integration, real integration between the CSA and the HSA, and it will fire cascading effects in combination with the physical events, and it will go finally to the HMI of the PSA, getting all the information that the HSA will send. So let's go for that. This is script running, and what you can see here is that the whole element has gone through. This is the message that has just been sent to the HSA as a result of it, and I'm going to change my my screen so you can share you can see the effect over the CSA. Okay, this message, this is I'm going to wait to, okay, you can see it now. And we have here the CSA sensing module interface. What we have just sent is, you see here in the right side, a new message, which is the one that I have just simulated the traffic, okay? Sorry, I have an error sharing my screen, but I'm going to do it again. Okay, let's see. Okay, and in this CSA sensing, we can see the signature that the sensor has detected. In this case, EdPro Trojan backdoor remote access Trojan connection added. This is directly said by the sensor Suricata. This goes through the CSA correlation with specific rules for for Trojan detections. And at the end, I'm going to log in here to see if an alert, CSA alert, has been detected. This is in real time. We see that we have detected here a remote access Trojan detected. I'm going to make it more bigger, easy to see. And the information is fully contextualized. Why? Because we see in which asset this has happened and which is the asset ID. Also, the group of PCs that this asset belongs to, and also what happened. And what happened is that our remote access Trojan download and installation has been detected because we have seen traffic associated to this malware. Of course, the criticality of it is critical, and that's the reason why you see here in red. And there is an explanation in case of the CSA team doesn't know exactly what is a RAT or what is a remote access Trojan. It says that it's a type of malware that allows to convert surveillance and administrative control or full control over the system that is running. So the idea is that over this PC, the attackers already have the possibility to remotely access to it and have full control, and they are already inside the port authority network, as Pablo commented and as you saw in the video. So now I give the floor, if it's correct, to my colleague, I think it's Javier, to see it has gone through the HSA. It should have been reached the HSA, and then he should have a final element in the HMI. You will see the HMI of in the PSA, the cyber view, and also you will see the effect having an event at this moment that has gone through the hybrid part, and it can be represented with the cascading effect.
Hi, hello to everybody. Thanks, Sergio. Yes, I can share my screen. As Sergio was explaining, the cyber event that he has generated has arrived to the action core of the HSA, and after that he moves to the test propagation engine, and after that we have received here in the HMI of the HSA representation, a message where we can show the event. As you can see, a window has popped here, showing that we have received a new cascading effect. Is from the cyber origin, and the type is malware. So we can show it on the GIS map, and as you can see here, we can zoom to the area, and we can see the origin of that event, what has been generated, and all the affected assets that has been considered for that kind of event in particular. If you click on any of those assets, you can see the consequence description that has been calculated for very specific assets, and also the suggested mitigation measures for avoid that cascading to carbon. So I can give the floor to my colleague Israel, who is going to show the HMI of the CSA.
Okay, so here we have the HMI of the CSA, and you can see that we have received several elements, so we can select to view the cyber incidents that have been received from the backend of the CSA, and here we see regarding the Port of Valencia information about the cyber incidents received in a particular device like this computer. So this is attack with this IP and this kind of attack, the date and such information. And also we can see another information here. And this information also is shown with these particular diagrams in order to have access on another kind of views at the CSA HMI, as Sergio was explaining previously. Also, this information can be seen with virtual reality glasses. And also, we can see elements of the attacks that have been produced. For instance, here we have the connection of the attack regarding the port of Piraeus here, and information about all the cyber incident. So now I give floor to my colleague Sergio again.
Thank you. I'm going to start sharing again my webcam. Okay. The next step, as my colleague Pablo mentioned.
Sergio, wait a moment, please.
Go to the video, right?
A vessel with a bomb inside a through the compromised computer. Attackers change the container position to an area.
Okay, so as you see, we are we carry on with the cyber situational awareness. So we have detected malware anomaly, a cyber incident. So, and we carry on with the system. So please, Sergio.
Thank you.
Comment a bit what occurs.
Yeah, this is the second step from the CSA. The attackers are already inside the organization. They have a point of access because they have remote access thanks to this malware installed. So they have already have access to this PC that was the place where they click on the email, and the malware was installed, and they have already control of it. So the second step is that they have control of it, but they install a second malware in another workstation, which has or is running the terminal operation system, which has control of the container location in order to move it to a location where they know they will nobody will have access to the cyber surveillance of the video cameras. Okay, so to do so, we have this as well as in the other situation. We have the same kind of traffic and information. In this case, what we are going to detect is not only the malware, but also the final effect, which is going to be that the attackers are going to modify the database of the terminal operation system application. They are going to move a container to another location because they are going to modify the database. So to do so, we click on that. And we finally see here, as in the other case, that we are sending as with correlation. The correlation has been detected in this CSA correlation. And what we can see at the end is that we are sending to the HSA for propagating the effect that the asset is different, is the asset ID number 168. We have a different event type, which is the 23, which is the unauthorized modification of a database. We have we say that it's an alert, of course, and we give also as you see, the coordinates, the geo position of the asset, as in the other case, and that's the reason why you can see in the PSA infrastructure and also in the CSA HMI a perfectly located asset that is affected. So now we are going to see the effect in the CSA sensing. I think it's this one. Sorry, this one. So first of all, in this section, again, in the CSA sensing, if we click on this, we see in the last 5 minutes, this is in real time as you see in the demo, another different access. We have here the previous one, which is a Trojan backdoor, the first step where they install the malware. And in this second stage, the message is different. This unusual database access to the TOS database workstation. It's a different type, it's a database access, and we also see the IP address affected. And based on that, and also using the correlation, we have detection for modification of databases. And we already have here another event that has already the information about an unusual database access, and we have detected an unauthorized change of the TOS database. The affected asset is the TOS, and the asset ID is the 168, and this is the TOS workstation database. And the kind of detection is unauthorized modification and deletion of information. So we have detected an unusual database access to the database workstation, and we report to the CSA team a suspicious remote traffic on the workstation, and we infer that there's a possible relocation of the containing information through the access. That we can say so because the TOS workstation, we have registered it as in the correlation rules as something that if you modify something in the database, then something is going on in terms of the container information. Okay, so that's the element. And as you saw in the message, this message as well as in the other one has been sent to the HSA, calculating the cascading effect, and it has also been sent to the HMI. We will see only since you already seen the cyber view of the HMI and the information is similar, we are going to see only in the PSA what's the event that has been raised in this case.
Well, as Sergio was explaining, and as the previous case, we have received a new event where the information fits completely what Sergio was explaining. A new event from the cyber part, which type is an unauthorized modification or deletion of the information. And also we can see information name and his identifier and the place where this asset is located. We have this new cascading effect that has been calculated by in our map, and once again we can see the effect generated for that specific cyber event, which is pretty similar to the previous one, but the information is different. Okay, now I think we can move to the next step. Pablo?
The terrorists enter the port during the night.
Okay, so we have seen in the beginning different cyber incidents, so a malware and also how affect a threat the TOS, the terminal operating system, that is crucial for terminal operations in order to the relocation of container. So then the SAURON platform, as explained by Sergio and Javier, is working detecting anomalies. So the main or the first incidents or the first events. But because the problem is that there is a bomb, as the video said, hidden in a container that is not detected yet, will be detected in the next steps. But the SAURON platform is working on. So now a fire is initiated in the servers, in the IT servers, because the reason of this incident is to switch off the cameras, to create problems and disturb the normal operation of the port. So the fire started here, and here starts the incident, the detection of the physical platform, or the physical situation awareness systems, who start to receive information. So please go ahead.
So now at this case, I'm going to share my screen, and the PSA will. The operator of PSA will know what's going on and will send that event to the HSA. So in order to do so, to manage this event, it will stamp it, generate it. So it's kind of fire smoke, and it's located at the server's room. So it's here at the server room, and well, type whatever kind, so it's not very critical. So I put a medium, I generate the event. So now it's at the PSA domain. We can analyze it, but as it's relevant, it will be sent to the HSA. So it's sent to the HSA, and I give floor to HSA.
Thank you, Israel. We have, as you can see now, receive a new event. In that case, a fire detected in a server room, and once it happens with the previous cascading effects, we can also show it on the GS map. and see all the affected assets that has been calculated for that particular event. As you can see here, the event has been originated in the Port Authority area, but affects also mainly assets in the area of the port terminal.
Go ahead with the video.
Where the cameras are disabled.
We have seen how the presence sensor detected the movement in the fence. So here we are combining with the physical domain, with the physical assets, and then the platform, the SAURON platform is working, combining the information. So the university now will explain the little bit, very briefly, the works of the PSA. Please.
Yes. So at this stage, there are several sensors located at the perimeter, and those sensors, as were explained before, probably will detect this presence and send it to the PSA. So I share the screen, and we'll see right now. Back to the PSA. So here we are, and the presence sensor is going to send to the PSA this event. So it's sending, and yes, you see that now it has popped on the screen. So it has been detected, this event, a detected presence at a particular location, of the perimeter. So now we can manage the event, we can maybe modify its criticality, but mainly what we're gonna do is send this event to the HSA. So I will send it. Now it's been sent, and okay, now we can see that now we have two events at the management console of the PSA. But now this event has been resolved by the HSA engine, the correlation engine, and the threat propagation engine that will produce information for the HSA HMI. So I give floor to my colleague Javier in order to check this.
Okay, once again, we have received a new event. A new window has popped up here on the presence, and due to the presence sensor who was located in the access fence, and as done previously, we can show it on the map and see the cascading effect calculated for in that particular case. Here we have the origin of that event and the different assets who are involved or can be affected by that intrusion. Now we get to the next step.
Terrorists start a fire in the terminal building to distract the attention of the terminal security guards and allow them to escape.
Okay.
Israel.
Yeah, so Rafa, you don't give us floor. I will continue.
Sorry. So yes, I was commenting that now we carry on with the physical part. So now we activate another sensor. This is the smoke and smoke sensor which sends the information to the PCA in order to disturb the installation and the distraction. And the platform, SAURON platform, receives this kind of information. So please, Israel.
Yes. So now we'll see that this sensor has provided information, and me as an operator of the PSA, I'm going to send this event to the rest of the system, particularly to the HSA. So this event was detected by the smoke sensor number 1. So it's here, and again, and the criticality is going to be medium. So I generate what I receive from the sensors. Now it's at my management of events, and PSA will send it to the HSA. Sorry, because I did click improperly, and now because I was trying to send a previous event, and the system detected it and said you cannot send what you sent previously. So now I'm going to send the proper event. I send it, and now it's been sent to the HSA. So I give floor back again to the HSA, to Javier, in order to see what's going on at the HSA.
Okay, then.
Then one more time, we have received here a new event who describes the cascading effect corresponding to that physical event. In particular, it corresponds to.
We cannot see your screen, Javier.
You cannot see my screen. Sorry. It's supposed to be sharing. Let me. I will done it once again. No.
Yes.
Now it's working. Okay.
Okay. Sorry. Well, I was saying that we have received a new corresponding to detected in a terminal building, as you can see here, and all the affected assets mainly in the terminal area.
Okay. Go ahead with the next.
Try to leave the port through one of the terminal exits. However, the facial recognition system from SAURON detects 2 unauthorized people, and an alert is sent to the security guard's tablet. Then the guards intercept the terrorists and arrest them.
Okay. So as you have seen, this is the drill that we have recorded. So as you can see, we will develop it a few weeks ago, but the idea is to think that is happening at this moment in real time. So the different systems are connected and are sending the information, firstly with the malware and the anomaly in the TOS, the cyber situation awareness. Secondly, with non-authorized persons in the building, so moving through the fence, as well as other smoke detectors from the physical part, smoke and fire, such as face recognition also. So all of this information is sending to this hybrid situation awareness. So here, permit to receive this information, or providing this information to the security officer, to the security officer, to making decision. So that is the most important. So we validate the physical situation awareness coming from the cyber, coming from the physical part, and the cyber anomalies or unauthorized access through the cyber situation awareness. And everything is sending to this in order to receive the information by the security officer and then taking decisions. And here, the PCA carry on working. So please explain a little bit what's happened
Yes.
with the receiving information, please.
Yes, Rafa. So now, while you were speaking, the video analysis module from IDEMIA has been done its processing, and I'm going to share the screen. And we'll see that I have received some message. So you see on my screen that I've seen that the PSA has received a couple of messages from the video recognition module with the face detection of two unknown persons detected in a restricted area. So we see both of these persons. We see also that the database picture is empty, obviously because they were unknown. So that information on real time and automatically has been sent from the cameras to the video analysis module, and the video analysis module has sent it to the PSA. So now the PSA operator will send these two events, these two face recognitions to the HSA to do what you were explaining previously, to do these calculations and to enhance the view of the hybrid situational awareness. So I send the first one, and it's successfully sent, and I sent this second one to the HSA. So I close and I send it, and both of them have been sent to the HSA. So I give floor back again to Javier in order to see those calculations.
Javier from IDEMIA, please.
No, it's not Javier from IDEMIA, but Javier from UPV.
Sorry, yes, sorry.
In that case, event non-cascading effect has been triggered by the been received for that particular event.
So we continue with the video in the next step.
Yes, we can hear you well. Okay, go ahead.
Due to the severe incident, an alert is sent to the authorities. Speakers announce the alert to the port vicinity.
For your safety, evacuate the...
Many people receive the alert by mail, telegram messages, Twitter, or the municipality app directly to their mobile phones. Finally, the bomb is deactivated and the alert removed.
As you have seen in the video, the main product of SAURON is the SAURON platform. You have seen there are different screens. One screen is dedicated to the PCA, the other one cyber situation awareness, and the third one is the hybrid, in which we received all the information coming from the cyber and the physical part, and the action or the decision taken by the PSFSO, so the security officer, will connect or activate the emergency population warning system. So that is explained by ETRA, by Jordi. So please.
Hi, Rafa. Thank you very much. I would like to share my screen and okay. Okay, perfect. So once the alarm is triggered, as I commented before, here we have the incident management platform in which Petra have been working. Well, when the alarm is triggered, we receive this message in our incident management platform. So here we have the description of the alarm trigger.
Jordi, wait a moment, please, because I think that Israel is going to send first the
Yes.
Okay, yeah, that's
Pablo.
right.
Yeah. So we were waiting to receive floor, but yes, first in the chain is that as you were saying, I'm gonna share my screen back again.
Yeah,
and
because
the first in the process is that the PSA operator detects that this bomb event is critical. The situation it's going out of scope, so it's going to generate an event in order to be sent to the HSA, as we've seen all the time, and then the HSA will be the HSA operator will be the one that determines that this is such as critical to be sent to the EPWS. So I'm going to generate that event, and this particular event is, as we were saying, a very critical one. So it's a bomb detected, and it's something that affects the whole port. That's why this event is not limited to the port environment, but also for the port vicinity, for the overall city, and that's why it's going to be sent by the HSA to the EPWS. So it's the name, and obviously the criticality is severe, so it's very serious. I generate the event, I save it, and very quickly I sent this event to the HSA to be processed by the HSA operator. So give floor to Javier from UPV back again.
Okay, thank you, Israel. Well, as Israel was mentioned, we have received a last and final event from the physical part, and that type is bomb detected. And we can show it once again on map. And in that case, as we were explaining, the main affected assets is in fact the port vicinity. So since due to that fact, the operator or the responsible of the HSA tool consider that both authorities and should be alerted, and for that case, we will send from that window that particular event to the EPWS system, and Jordi from Metra will show us how that information is received.
Okay, so let me share again my screen. Okay, so as you can see, a new incident has come to the incident management of the EPWS platform. The title of the name is bomb detected. And here we have not only the incident, but also the different notification means in which this incident has been spread. It has been spread through the Telegram account. It has been spread also through Twitter, and in this case, through different emails. Okay. And also it has been spread through the different smart city platforms, but of course it cannot be checked in this case because they are a real platform, so it is not a way to compare it. Okay. Well, when we have the incident trigger, we have the Telegram account. As you can see, the thread has been arrived to the Telegram account, and also to the Twitter account. In here in this case, maybe I should refresh. Yeah, here you have it. The new incident in which a bomb it was detected. Okay. The incident management platform has also a map in which this relevant information could be interesting for the operators. Okay. when they have to deal with the threat. And here you have the details in relation to what has been happening in the port. Okay, and also it is possible.
Can you stop sharing your screen and share it again, because someone is having problems to see it?
Okay. So what should I do?
Stop sharing and
okay.
share again.
Okay, let me check in. But I cannot share anymore my screen, Pablo. Now yes. Okay. Okay, so as I was mentioned, here we have the map in which in a single view you can see where the alarm has been triggered and the relevant information to this alarm. Okay, and also as I commented before, here we have the different notifications mechanisms in which
Okay, some problems with the connection. Jordi? Can you hear me? Pablo?
Yes, it seems that Jordi is having some connection problems.
Okay. So then, don't worry. We go ahead with the video, and at the end, is Jordi connected? Is the final part of the video? So can explain the warning system.
Thanks to this, which has made it possible to repel the attack with the least possible consequences for people, infrastructure, or goods. Would you install the SAURON platform in your port?
Okay, so well, we have see the video step by step with the detailed information, because our main objective is explain how works the SAURON platform, depending on if we receive cyber incidents, physical, because the idea is validate the system. So we are mentioning some examples of sensors and technologies. However, we can include others. So this has been a particular scenario. So to demonstrate the combination between both of them, and how we send this information, as I said before, to the emergency control center. So you have seen some images about different screens that we receive the information, and the officer has this information in advance also. So it's correlating both of them. And the idea is has a very friendly interface. When I say friendly, is with an advanced visualization, as the university said, with new technologies and new identification sensors in the cyberspace. So the idea is provide this information. So the SAURON platform contains many elements. We have showed you during the scenario a small part of the capacities, because the idea has been this interoperability between the different systems. And now, please, I propose you to bear in mind the explanation as maximum as possible, because we are going to run the video, the full video, and then check all the scenario, all the scenes, all the images without any interruption. So please go ahead with the video.
receives a fraudulent email with malware. The attackers take control of the computer. A vessel with a bomb inside a container arrives at the port of Valencia and berths in CSP Spain Valencia terminal. Through the compromised computer, attackers change the container position to an unguarded area. The terrorists enter the port during the night and initiate a fire to disable surveillance cameras. Next morning, the terrorists jump the perimeter fence of the terminal where the cameras are disabled. The terrorists gain access to the container and activate the bomb. Terrorists start a fire in the terminal building to distract the attention of the terminal security guards and allow them to escape. The terrorists try to leave the port through one of the terminal exits. However, the facial recognition system from SAURON detects 2 unauthorized people, and an alert is sent to the security guard's tablet. Then the guards intercept the terrorists and arrest them. Due to the severe incident, an alert is sent to the authorities and population using the EPWS. The message is shown in traffic and public transport panels around the city. In addition, loudspeakers announce the alert to the port vicinity.
For your safety, evacuate the...
Many people receive the alert by mail, Telegram messages, Twitter, or the municipality app directly to their mobile phones. Finally, the bomb is deactivated and the alert removed. Thanks to the SAURON platform, there has been a rapid and coordinated response to the terrorist threat, which has made it possible to repel the attack with the least possible consequences for people, infrastructure, or goods. Would you install the SAURON platform in your port?
This has been the video, so I hope you enjoy it. And well, we have explained the different actions from the SAURON platform. Indeed, as I mentioned, we have to show that it could be in real time. So the constant of the COVID has limited to us to do remotely, but we have tried to do our best validating the different systems. And now we move on the questions and answer session. So any query, comments, I propose to all the presenters to switch on the cameras in order to be online. So please, Sergio, Javier, Jordi, everybody, please switch on your cameras. As I said, we have the chat. You can write your comments, your questions in order to answer. Some of you also could connect it if you want. So then I propose to start with the comments and questions that we have received during the presentation, and after that we spend also time to give you the floor, to attend the floor in order to comment or send a suggestion. So the first question that we have received is about the will facial is addressed to CSA. no, sorry, so IDEMIA about the facial recognition. So
Yes.
will facial recognition work with people wearing COVID-19 masks and face coverings? So that has been, yes.
Yes,
this
yes, it's a very good question. Thank you. And yes, we worked hard on this topic. And yes, it works pretty well. There is a small decrease of accuracy, and it can take a little more time to process. But it works really well, and especially in this context, in this kind of use case, because for port security, the personal database is only, let's say, hundreds or thousands of people, but not millions. So yes, it works well with mask, and it works well even with glasses and even sunglasses.
Okay, many thanks. So other questions for this time to the CSA is that the CSA considers to take as input some news about very recent cyber attacks in other ports, so that special attention can be paid to the port system?
Yeah, thank you for the question. This is also a very good question from this side, because the CSA and the whole project has to be prepared against new threats and new types of attack. Not only the special comment will not only be about only ports, but also for any attack for companies. But I get the idea of the question, because Joan is trying to also consider the specificality of the attacks that can be suffering other ports. So the question is, yes, we support our system with these new types of cyber attacks, and the way is to have a updated rule package, which is called emerging threats. And this emerging threats is trying to gather all the new types of attacks that are not only raising in ports, but also in any type of organization that is currently being attacked every day. So the idea is to update periodically update these emerging threats, which are a rules package that is going to look for concrete patterns of these new types of malwares, of denial of service, of attacks. And that's the way the CSA covers these new emerging threats.
And following to this question, there is another one, a second question that is about are the CSA, PSA, and the hybrid situation awareness run at the local port service, or can they be run on the cloud?
Yes, my response about that is depending on what it concerns to the CSA. The CSA is based on a CM product from S2 Grupo, which is Gloria, and we have advanced. This is the way also we enhance our product, going towards advancing to the cyber view and also to the coverage of the port attacks. And since Gloria is the base platform from the CSA, and we are deploying Gloria already in the cloud from customers, we are having already some customers running on the cloud. So for the CSA, it's already covered.
Yes, and also, Rafa, I would like to point out something.
Yes, please.
Very useful and very interesting about this COVID-limited demo that also provides very nice insights. As the demo has been run everything virtual, so systems are located. Some of them, for instance, in UPV Cloud. Some of them are at Javier house. Some of them are at my house. Some of them, as Sergio was explaining, are located at their Grupo C2 facilities, AIT facilities. So overall, from the perspective of the SAURON system, yes, it can be run in a cloud approach. No, it's not limited to be working on the port facilities. I think for the overall components of the SAURON. So it's a good news that this COVID limited demo has provided a real testing of this cloud capability of the SAURON system.
Yes, indeed, I agree with you. And we have commented in the beginning, it was a pity to not not developing the drill in a real scenario. But also, the COVID constant has give us the opportunity to demonstrate the remotely the different capabilities of the technology, that we can show the different parts, the communications, interoperability. So I think we believe that it is also has had a positive action in order to demonstrate, as you said. So not local, also in the clouds, from remote, everybody are still working from home, and we can show the details and the different results achieved in the project. So thank you for your comment and your inputs. So carry on with comments and questions. I have another interesting question. So thanks for your comments and your queries. So it's more focused on training. Maybe here the university can give the replay, knowing the platform, the physical and the system platform. So the question is, how many people will need to be training in the use of SAURON of Valenciaport for it to be an effective tool? How long will be training take? So I will comment also, but maybe Israel, you have comments about the use of the tool.
Yes, yes, it's a very interesting question. And well, take into account that all of the tools, all of the HMIs and all of the tools involved in SAURON have been designed with simplicity in mind. So if you've seen the usage we've done, all of us, we've been doing during this demo of the tools were very simple on its usage. So in order to do whatever kind of action, few clicks were enough in order to perform that action. And also, each of the tools was oriented, it was action oriented. So for instance, events pop up in case of a PSA, and you analyze the event and send it to the HSA or see it on a screen. The same happens with HSA. The same happens with CSA. So as tools are that simple, and also, if you remember the presentation, for instance, the mobile PSA for port police officers moving around the port also were clickable on the screen, so very simple to manage. That's one point regarding the time needed and the time that should be used for training these people. On the other hand, from our perspective, we've been doing training for tools for responders, training for tools for military people for the last 15 years. And with this kind of tools, with our experience training them, in a few weeks, whatever group of headquarters officers or on-field officers can be properly trained in order to benefit and take advantage of these tools and provide an enhanced operation due to the usage of these tools with, as I say, very limited time period training. Okay.
Yes.
Regarding, can I add something? Regarding the people to be trained, usually the port has two different teams, the IT team and the physical security team. So in this case, we should provide training for both of them.
Yes, yes, indeed, as following with the Pablo comments, so the port has the IT guys that is controlling the servers and the communication systems, also the security, but with the security people, we talk about port police that are with the control and surveillance of the port area, but also we have to mention the target of this tool is the emergency control center, where we find people, apart from the security officer, people checking all the time, monitoring the port by the different sensors. So we have different profiles, but at the end, Israel said it's friendly. The use of tablet was training to the port police, so it's not difficult. It's very easy to know the GPS and where the resources are, and receive the information with the experience of the university, also with the Spanish Army, is a good background. Okay. So more questions. I have another question. This question is from the project officer of the officer that I would like to thank you, Nikos, for attending the meeting. Thank you very much, as well as to the reviewers that is online connecting to this pilot demo. So thank you. So I would like to transmit the comments. So well, it's focused on the tier L. So taking from your last question in the video, which is the final tier L achieved for the integrated systems, and are concrete plans to install this, at least in the port participation in Sauron. So is procurement planning to take place in this port? So well, here I would like to say that we have advanced with the Sauron platform. Now we have tested the well connections, and the idea to create or to build the platform. So here maybe the different leaders of the platforms, I would like a few words about what is the situation. I advance that we have not started any procurement, as mentioned it, for the installation, but yes, we are in contact with the port authorities in order to check about the installation in a first approach. So maybe university as leader of the PSA, cyber and warning system, and also Thales and IDEP, please start with UPB. Have you started this kind of platform in Spanish Army? So could be the first step to explain.
Yeah, I mean, as we were explaining previously, this SAURON PSA comes from a system which it's been around the Spanish Army since 2008. Okay, so it has a very high TRL level because it's been tested, as we commented, in international missions. So, I mean, it's a very hard environment that stresses the system and provides a lot of insights and inputs to enhance it from the perspective of the TRL. That's why we wanted to provide all that knowledge to the SAURON platform, okay? And the same happens to our developments regarding CSA and HSA. We've been reusing all the knowledge that we've been doing not only in research projects, but also in real systems which are currently used 24/7 in several environments, such as military. And also, I think that the same happens to other platforms involved. For instance, Sergio was commenting Gloria, which is a product which is working since a lot of time. So that's the ground base for the development in the CSA. And I think the same happens to EPWS and so. So I give floor to my colleagues, but I think TRL is very high in all the components.
Yes, thank you, Israel. In the case of the CSA, I have to comment that Gloria is the official CM for the National Cryptographic Cert of Spain. So the level of TRL, of course, as you might imagine, is the highest because we have to cope every day with security incidents in one system that is called the early warning system from all around 250 public agencies and companies that are added to this national cryptological threat in Spain. So the level of TRL in this case is the CSA is based on this Gloria system, and we have had the opportunity to enhance it moreover in terms of orienting to the port authorities.
Okay, so are you saying that Gloria is on the market? So
yes.
One could use
sure.
by the CNN?
Yes.
The highest TRL at this moment. Okay, so also following the question about the web we plan to install this platform, I would like that ETRA is working on the exploitation plan, has defining the different aspects. One question is when we plan to do that, but also we talk about the scalable of this tool. So I'm going to refer to other question and we can answer both of them. So the piece of information. So the idea is just a moment. I was checking that. So the first is when we plan to do in the market, and also I take in advantages to comment. It's possible to structure the platform in different aspects. So in separately, or it's better to install as a whole. So please, Jordi, what is the definition during the exploitation plan? Please inform us the different words.
Thank you, Rafa. Well, we provided an initial estimation of the cost in relation to the different solutions, but we provided this raw estimation of prices and installations at the very beginning of the project. Now we have more robust tools in which all are well deployed and installed in the different ports. So the basic idea is to proceed during this month and also taking into account the previous work done, how we can expect that these solutions could be deployed in the different ports. So we can take two different points of view. One of them is that each system can be independently sell as a separate solution, but we can take into account that also Sauron, it can be sell as a robust platform in which it could be aggregated all the different systems provided. So this is the two different points that we are going to proceed in this case, and we have to take into account the dimension of each port. Of course, the same solution, it cannot be applied for the different ports because as you commented, Valencia and Piraeus, they are very big ports, but we have to take into account that our idea is to provide this solution for also different ports that could not be bigger as the project as the Valencia and Piraeus ports. So essentially, this is.
No, please.
This is how we would like to proceed, having two different points, selling the products by their own, and trying to go to the market as a whole solution.
Okay, so we can say that this is a question to all of us, and to you all, of course. So we can say that there's a mature result. We have a mature result with a high TRL. So we are now at this moment, we can install the platform, the Sauron platform. I don't say today, but in the near future. So maybe 1 year. So we are in conditions to do that because we have developed all the main aspects. So the idea is to install in the near future. So I don't know if Idemia, that I received some comments, wants to comment something about the installation and the plans for these products. Xavier?
Yes, no, as I said, yes, Idemia technologies are now very mature and with a high TRL level because we integrated into a product that we sell, and so it's ready to be integrated with Sauron, and of course we have some features that are still at research and development stage, but the main features like face recognition are really works very well as I explained. And so, yeah, for our side, we are ready to sell it and to work with.
Yes,
with
since today, yes, we can say that we have developed any the procurement yet for agreements with the Port Authority, but since today, yes, we are in contact, or we are in a condition to be in contact with ports, explaining the platform, and then checking with them the future steps in order to be able to install a platform like this. Okay, so move on the next one. We have other questions. So, well, it's coming from, it's more focused on the warning system. So it's an example that is coming from Tony. So you will probably, it's for you, Jordi, you will probably remember the major explosions in Tianjin port in China in 2015. There were estimated a high number of deaths. How could the defense system has to coordinate among them in order to send information to?
Yeah, exactly. Rafa, the basic idea is to thanks to the APWS, the different emergency systems could be coordinated in order to solve the problem and try to have accurate actions when they have to deal with a critical situation. In relation to if it could help in order to reduce the number of deaths, it can prevent. It's a prevent tool in order to help the citizens that a kind of problem is happening in a point of the city, but and also to help to the different security services to work in a single platform.
Yeah.
But
then you say that this provide the emergency warning systems connecting with different systems. We have seen the different tools that you use, the Telegram, social networks, also connected to the traffic panels and so on, permit a very quick evacuation. So in case of an explosion or some of problems, so the dissemination of the message, and also not only to inform all of them if how to act with the traffic lights, with the direction could be changed in order to open the access out of the port, open the access out of the city. So this kind of quick reaction, fast response, could be reduce the number of deaths, isn't it?
Yeah, that's right. Thank you, Rafa.
Okay, so then we are almost on time. So I would like to thank you very much, you all, for sharing your time during these 3 hours. I hope that you find interested in this project. I would like also to remember you the SAURON website, where we are going to include the link of this session that we are recording the session. Also, if you have comments, please let us know your comments via website, or there is an address email in order to send your comments. Thank you very much. But before leave the floor, also to remember the survey that we mentioned it in the chat and during the beginning of the session. You can check. It's a very short survey. We will be grateful to receive your comments. And nothing else. Thank you very much to you all again, and stay healthy. That is important. We are getting better, but I wish you all the best, and the most important is our health. Thank you very much, and we keep in touch at the different websites and emails. Okay, thank you very much. See you. Have a nice day. Bye. See you. Bye.
Thank you.
Thank you, Rafa.
Goodbye.
Goodbye. Thank you. Goodbye.